Our goal is to find the Laplace of the linear combination between 1 and 5t. Basically, you can separate this into the Laplace of 1 plus Laplace of 5t and calculate each one of them separately. And remember the definition of Laplace transformation. Basically, it's improper integral 0 to infinity of e to power negative st f of t dt. So we're going to calculate each one of these separately. For the Laplace of 1, this is the integral 0 to infinity e to power negative st times 1 dt. This is simple use of if u is equal to negative st, du is negative s dt. So the Laplace of 1 is equal to negative 1 over s times the integral is 0 to infinity, that you can change this using u sub. You can do this right now or apply it later, e to power u du. So the Laplace of 1 is equal to, here you have negative 1 over s, e to power u, which is basically e to power negative st, and the t ranges between 0 to infinity. For simplicity, you can rewrite this as positive exponent. So you have negative 1 over s times 1 divided by e to power st. T ranges between 0 to infinity. But if you plug in infinity, it becomes just 0 minus negative 1 over s and 1 divided by e to power 0, which is 1. So the result of the Laplace of 1 is equal to 1 over s. So this guy is 1 over s. Now we just need to calculate the Laplace of 5t with the same process. Let me change the color. For the Laplace of 5t, Laplace of 5t, the process is the same. You have the improper integral 0 to infinity e to power negative st 5t dt. For this guy, we're going to use improper integral and the method of integration by parts. Apply integration by parts. Let me write this guy here so we have enough space. Integration by parts. Let's take u to b. You can basically take this 5 and write it outside your integral for simplicity, and u is equal to t. And then dv, let me change the color. dv is equal to e to power negative st dt. So your du is dt, and basically your v is equal to the integral of e to power negative st dt. So your v becomes negative 1 over s e to power negative st. So the Laplace of 5t is equal to 5. Let us open the bracket, uv, which is t, times negative 1 over s e to power st. I'm going to write it on the denominator because when I apply 0 to infinity for t, it is on the denominator and it makes it much more easier to do the calculation. Minus the integral of v du, which is negative 1 over s e to power negative st, and du is just dt. Let's close up the bracket so we can continue. Again, please pay attention here. If I plug in infinity, the denominator goes to infinity much faster than the numerator. This becomes 0. So far we have a 5 multiplied by, here you have a 0, minus, you have another negative sign, but this guy is also 0, right? If I plug in 0 for t, this becomes 0 as well. So this guy is going to be just 0 no matter what. You can just erase this part. So you have a 5 multiplied by Laplace of 5t is 5 times, here you have 1 over s, the integral of e to power negative st dt, which is easy to calculate. As usual, let us u be negative st, du is negative s dt. So the Laplace of 5t can be written as 5 divided by s, and here you have the integral 0 to infinity of e to power negative st dt, which can be written as e to power u times negative 1 over s. So negative 1 over s e to power negative st, and your t ranges between 0 to infinity. So the Laplace of 5t is nothing but 5 over s times negative 1 over s. So you get negative 5 over s squared. And if you plug in infinity, this is 1 over e to power infinity, which is basically infinity. So the Laplace of 5t is equal to negative 5 over s squared. And here you get 0 minus 1 divided by 1 or 1. So you have 5 over s squared. But this is the Laplace of 5t. S divided by 5 divided by s squared. So you're going to copy this guy down here. 5 divided by s squared. So the Laplace of 1 is 1 over s, and the Laplace of 5t is 5 divided by s squared. So you can write it this way. The Laplace of 1 plus 5t is equal to 1 over s plus 5 divided by s squared. So again, because of linear combination between 1 and 5t, I can separate this and calculate the Laplace transformation of 1, and then calculate the Laplace transformation of 5t, and then add them together. For the Laplace transformation of 1, we are basically following the definition of the Laplace transformation. The improper integral 0 to infinity e to power negative st f of t, but f of t in this case is just 1. So you're basically calculating the integral of e to power negative st. For the Laplace transformation of 5t, the linear function, this is basically the same process, but here you're applying the integration by parts, because you have t multiplied by e to power negative st. So u is t and dv is e to power negative st dt. With the method of integration by parts, we found the Laplace of 5t, which is 5 divided by s squared. So we could go back up here and write down the Laplace transformation of 1 plus 5t, which is 1 over s plus 5 over s squared.